Hello geometers, here we are again with Circle 7, Lengths of Tangents and Secants. Today we only have 4 items that we have to cover, so let's number them. 1, 2, we have 3 and 4. Okay, so just like yesterday's, you have to know and memorize these, starting off with number 1. Where we have 2 tangents drawn from an external point, then the tangents are congruent. So star, star, squiggle, squiggle, have to know it, memorize it, visualize it, draw it, know it. So we have common point P, which means that tangent PA is congruent to tangent PB. Those 2 segments are congruent. On to number 2, which says, if 2 secants are drawn to a circle from an external point, the product of the lengths of one secant and its external segment is equal to the product of the length of the other secant and its external segment. So it says PB and PD are tangents. Here they are, common point P. Tangent, remember, starts at a point and touches a circle in 2 places. So we have 2 tangents here, or sorry, 2 secants. So the equation would be PB, that's the length of the entire secant, times PA, which is the external portion, is equal to the entire length of the other secant, PD, times its external portion, which is PC. So, in general, you could say that the whole thing times the portion that's outside is equal to the whole thing, the other secant, times the portion that's outside of it. We didn't star, star, squiggle, squiggle, so let's get that in there. Star, star, squiggle, squiggle. Squiggling, squiggling. It's important. Know it, recognize it. Number 3, very similar, except for in this case we have a tangent and a secant. So the rule is if a tangent and a secant are drawn to a circle from an external point, the tangent is the geometric mean. Remember that? We did that before. That means that the tangent segment, PA, is the denominator of one fraction and the numerator of the other in a proportion. And we are talking again about the entire length of the secant and the external portion. So here we have star, star, squiggle, squiggle again. Star, star, squiggle, squiggle. So if you were to take the first step in solving this proportion, if you multiplied this cross product property, you would get PA, which is the tangent squared. And if you thought about it as being the whole thing, which is PA, times the portion that is outside the circle, which also happens to be PA, you would end up with PA, which is the tangent squared, is equal to, and on the other diagonal we have the whole secant, which is PB, times the portion that is outside its circle, which is PC. So again, we have the whole thing times what's outside equals the whole thing times what's outside. And number 4 is if a tangent and a secant are drawn from a point outside the circle, then the product of the lengths of the secant and its external portion is equal to the square of the lengths of the tangent. Well, that's just restating number 3, which is what we just did above. So star, star, squiggle, squiggle, you can think of it whichever way you want as long as you know it. So the tangent squared, in example 4, the tangent is segment BP. BP squared is equal to the whole secant, which is PA or AP, times the portion of it that's outside, which is CP. Okay, so now we have gone over those 4 things. We have a couple of examples to do. Example number 1 says use the variables to write the equation based on the segments. Well, if you look here, we have a tangent, which is BP or PB, and then we have a secant, which is CA. So we have the tangent secant combination. So we would have to apply rule number 3 or 4, which says the tangent squared and that would be our variable x to represent that length. So we would have x squared is equal to the length of the entire secant. That is the sum. So you're thinking of the partition there, segment partition. The whole thing would be y plus z times the portion that is outside of the circle, which is y. Now you could leave the equation like that, or we could go on and distribute, which means we would get x squared equals y squared plus yz. So either of those would be fine. Let's turn to the next example. Example number 2. If we're looking at our circle, they want us to do the same thing. Here we have two secants. So again, it's the whole thing, the whole secant, which would be x plus y, times the portion that is outside of the circle, which is just y, is equal to the other whole secant, which would be z plus w, times the portion that's outside of that circle, which is just w. Now again, if we applied the distributive property, we would get y squared plus xy, writing this in standard form, largest exponent comes first. So we have y squared plus xy is equal to w squared plus wz. Okay, moving on to example number 3. Here we have some actual values to apply to those rules. So number 3 says solve for x. Here we have a tangent, which is PD, and a secant, PW. So here we're going to use the rule that the tangent squared is equal to. So our tangent is 8. So we're going to come up with 8 squared is equal to, the length of the entire secant is 16, and the portion of the secant that is outside of the circle is x. So here we have 8 squared would be 64 is equal to 16x. Dividing both sides by 16, you end up with x is equal to 4 for number 3. On to number 4. It says find the perimeter of the triangle. Well, if you look, the triangle is the outermost shape, but its tangent, it has a bunch of tangents to it. So if you look up here, we have a common point. So 5 would have to be, this is a tangent and this is a tangent. So if this segment is 5, then this other tangent from the common point would also have to be 5. And if we looked over here, if we use this common point, we know that this tangent length is 4. That means the x tangent length is also 4. And lastly, we have this tangent, which is 7 from a common point, so z must also be 7. And then to find the perimeter, you know, we add up all the sides. So we're going to add them in parts here. I'm going to start with this segment here. So if we go right around the triangle, we have 5 plus 4 plus 4 plus 7 plus 7 plus 5, and if you add all those up, the perimeter is then equal to 32. So that's number 4. Moving on to number 5. Our segments here that we have two secants. So again, we have the whole thing times what's outside is equal to the whole thing times what's outside. So here, secant PB, we have to take that sum, so it's the whole thing, which is going to be 15 plus 5, times the portion that's outside would be 5, is equal to the entire length of secant PA. They gave it to us as 25, and the portion that's outside is the x. So 15 plus 5, applying order of operations, we're going to add the 15 plus 5 first. So we have 20 times 5 is equal to 25x. 20 times 5 is 100, equals 25x. Dividing both sides by 25, we find that x is equal to 4. Number 6, our segments here, we have again a tangent and a secant. So our rule says the tangent squared is equal to the whole length of the secant, which is 9 plus 3, times the exterior portion, which is just 3. X squared is equal to 12 times 3. 12 times 3 is 36, so x squared equals 36. Take the square root of both sides, square root of x squared, square root of 36. We get x is equal to 6. And last but not least, example number 7. Again, we have two secants. So it's the whole thing. We're talking about secant PC. The entire length of secant PC is going to be x plus 4 times its external portion, which is 4. Set that equal to the entire secant PD, which is 10 plus 6, times its external portion, which is 6. We're going to have to apply the distributive property on the left-hand side, so we end up with 4x plus 16 is equal to, order of operations here, 10 plus 6 is 16 times 6. 4x plus 16, and then we get 16 times 6 is 96. Now we can just subtract 16 from both sides, which leaves us with 4x is equal to 80. Dividing both sides by 4, we end up with x is equal to 20. Okay, there you have it. Examples and the rules. Review it if you need to, otherwise be prepared for class tomorrow.